Here we have a graph of current passing through an inductor, and we are supposed to determine and plot the corresponding voltage across the inductor. So what we need to remember for this one is that the voltage across an inductor, V of t, equals L di dt. So what we can do is find the slope in different places, because the derivative, the slope of a curve gives you the value of the derivative. So for t less than -4, you can see we have a horizontal line, which means that the slope, di dt, is equal to 0. So for t less than -4, v of t equals 0. When t is between -4 and 2, -4 and -2, then we can find the slope by looking at rise over run. So v of t equals L, which is 0.1 millihenry, so 0.1 times 10 to the -3rd, times di dt. So that's rise over run. So from going from -4 to -2, we go down 3, so -3, and over 2, so -3 over 2. So we have 0.1 times 10 to the -3 times -3/2, which is -0.00015, or -0.15 millivolts. Now from -2 to 2, -2 is less than t is less than 2, once again we have a horizontal line, and so the slope is 0, so v of t equals 0. From 2 to 4, so 2 is less than t is less than 4, v of t equals L di dt. L is 0.1 times 10 to the -3rd, and di dt is the slope. Rise over run, you go up 3 and over 2, so that's 3/2. And it's the same as on the negative side, just only this time it's positive. So this is 0.15 millivolts. And then once we get on the other side of 4, once again our current is horizontal, and that has a 0 slope. So for t greater than 4, v of t equals 0. Specify those time intervals during which power is transferred into the inductor and those during which power transfers out of the inductor. Also specify the amount of energy transferred in each case. So let me just make a little chart here. We have our intervals, so we have less than 4, less than -4, and then we have -4 is less than t is less than -2, and then we have -2 is less than t is less than 2, 2 is less than t is less than 4, and t is greater than 4. And in each of these time intervals, let's take a look at the current and the voltage. We just found the voltage, so I'll fill those in here. So the voltage, we had 0 here, 0 here, 0 here, -0.15 here, and +0.15 here. Our current, just looking at our graph, is less than 4, it is a value of 3. Greater than 4, it is a value of 3. Between -2 and 2, it's 0. And in between -4 and -2, and from 2 to 4, it's a line. But we can see that it's always positive, and that's going to be what's important here, so I'll just put positive. Now it's asking for power, so power, this is I, power equals IV. And we want to find out if power is transferred into the inductor or out of the inductor. So we want to know, is power absorbed or supplied? Or is it positive or is it negative? Well, from less than 4, it's 0. Between -4 and -2, we have a negative times a positive, that's negative. Between -2 and 2, it's 0. Between 2 and 4, we have a positive times a positive, which is a positive. And greater than 4, we have 0. And remember, a negative power means it is supplied, and a positive power means it is absorbed. So when is power transferred into the inductor? So into the inductor is where it's absorbed, and out of the inductor is where it is supplied. Okay, and now we want to know, now we want to know how much, how much energy. Okay, so we want to know how much energy. Well, let's take a look at from -4 to -2. That's when power is being transferred out. So we have at -2, let's figure out the amount of energy that is stored in the inductor. The amount of energy that's stored in the inductor at -4 and the amount of energy that's stored in the inductor at -2, and the difference between those two is how much was transferred out. So we know that energy equals 1/2 Li squared. So at -4, at time equals -4, our energy equals 1/2, and L is 0.1 times 10 to the -3, and I is 3 squared. So we have 0.5 times 0.1 times 10 to the -3 times 3 squared, and that equals 0.00045 joules. So at time t equals -4, it has 0.00045 joules, or 0.45 millijoules. But when it gets to t equals -2, the current is 0. So W equals 1/2 times 0.1 times 10 to the -3 times 0 squared. And so this is just 0. So how much energy was transferred out? 0.45 millijoules was transferred out. So from -4 to -2, 0.45 millijoules was transferred out. Now you can see the shape of the curve is exactly the same from 2 to 4 on the other side, and so that is when energy is being absorbed. And so by the time you get to time t equals 4, the inductor will have absorbed that energy. So this one was from -4 to -2, 0.45 millijoules transferred out. And from 2 to 4, 0.45 millijoules transferred in.